the purpose of today now is we're going to look at a special derivative relationship between functions that are inverses. And there's the big answer to the question I asked you a moment ago. I asked you to graph f of x, I asked you to graph g of x, and I asked you to graph the appropriate tangents as asked for. I said x equals 2 on f, I said x equals 0 on y. I want you to take a look at the graph that I borrowed. I borrowed this graph, okay? This green graph right here is f of x. The purple graph is g of x. Based on that picture, how are f and g related? With confidence, everyone. They're inverses, right? They're inverses because they're reflections over that red dotted line that I just gave you, right? F and G are inverses. I did that on purpose. I wanted a picture to kind of go along with today's notes, and that's why I added this example in. Okay, now, I asked you to look at two specific points. I asked you to look at x equals 2 on F and x equals 0 on G. What is the special relationship between those points? They're inverses, and I chose those points on purpose. Okay? Here is the tangent to F at 2, 0, and here is the tangent to G at 0, 2. What do you notice about them? They're inverses. What's the slope? What's the slope of this one? 1/4. What's the slope of this one? Can you explain why one of them is 4 and one of them is 1/4? I'll pause this for a second while you discuss. How do we explain the fact that the slopes are, what's that word? 4, 1/4. What's that word? Reciprocals, right? How do we explain, knowing that they're inverses, how do we explain the fact that the slopes are inverses? Do you want to explain, or would you like me to? I'll see what I can do. Let's look at F. When we look at F, if we were to rise and run, this would be 4 and 2, right? On f of x. No, I'm sorry, that would be 4 and 1. My bad. Slope's got to be 4, guys. 4 and 1. Rise 4, run 1. That's a slope triangle on the tangent for f at that particular point. Okay? On G, if I were to rise and run, I would rise 1, run 4. Which is a reciprocal idea, right? But let's explain that in the context of inverses. What is the definition of slope from algebra 1? Rise over run, which is change in y over change in x, right? What happens when I invert a function? The x's and the y's trade, right? So would it then make sense that the slope of the inverse, this is not appropriate mathematical notation, the slope of the inverse is change in x over change in y? That would make sense, wouldn't it? Okay, now the question is it always true, or is it just a coincidence? Look at the graph, find another point on those graphs where they have that special inverse relationship. Like, don't pick a point here with a point out there. That doesn't make sense. It only follows for a particular point. Look at another point on the graph in the inverse and convince yourself that the slopes at those points would also be reciprocals. And then answer the question, do you think it's always true? Do you believe it? Okay, it's believable that it's always true. I wanted to give you this picture representation because we're about to go into the symbolic nature of it. You ready for the symbols? I'm about to prove it with letters. You want to see that? Of course you do. You always want to. You love that part. So let's take a look. Here's our goal today. Our goal is, in particular, looking at inverse functions, how to find the derivative in inverse given only the original function. Okay? All you need to know, you don't need to know an equation for an inverse. In this example, I gave you an equation for f, and I gave you an equation for f inverse, didn't I? if I gave you an equation for f that you couldn't find the equation for f inverse, you can still find the slope, and that's the point today. Okay? We didn't talk about how my graph was different than yours, likely, did we? How was my graph different than yours? What am I missing? I'm missing the left half of the parabola. Knowing what you know now about the relationship between f and g, why did I get rid of the left half of the parabola? They have to have the same domain and range. What's that phrase? The function has to be 1 to 1 in order to have an inverse that's a function. Cool? All right, let's go to this now. I'm going to skip today's class opener, and I'm going to go down to this. This is, I'm going to do this symbolically, and we're going to do, I'm about to prove what we just came to the conclusion of, all right? So what I'm about to do isn't really any different than what we just did. It just has more specific notation with it, and it allows this to be true for every pair of inverses. So here's what we want to do. We want a function, and we want, goodness gracious, that's a mess of notation. This is f inverse of x prime. The book also uses this, f inverse prime of x. Those are the same. The book uses the notation I wrote in blue. It's also acceptable to write f inverse x of prime. The whole goal of this is we want the slope of the inverse of f. Okay? And we're looking for a special relationship. I'm going to start by taking you back to pre-calc. True or false? True. Why? If you compose inverses, you get the original back, right? That's the whole point of an inverse. That's a definition of an inverse. Okay? This is from, we'll just say definition of inverses. Might not actually be the exact definition, but it's a really, really, really important property of inverses, right? Okay? Now, I'm going to go ahead and for this problem, I'm going to let g of x replace f inverse of x. Okay, that's for this particular problem. I'm just going to rename f inverse because the notation is cleaner if I get rid of the fact that we're dealing with an inverse. Because we don't know how to find the derivative of inverse, but we do know how to symbolically find the derivative of g. It's not as hard as you think. Okay? Good so far. All right. So our goal, as of right now, is to find g prime of x. Right? Because g prime is the derivative of the inverse, which is what we're trying to get. All right. From the pre-calc statement, I'm going to jump down here. From the pre-calc statement that we agreed to be true, using the fact that we're going to rename f inverse, we renamed f inverse, we called it g now. All right? We just gave it a new name. I'm going to rewrite the pre-calc statement. F of g of x equals x. I haven't changed anything. I've just given it a new name so I can differentiate it a little bit easier. Okay? If g is f inverse, this is also true from that whole composition of inverses idea, right? And again, disclaimer, you probably don't have to do this again. This is just proof of what I just showed you on the board, though. Okay? Let's differentiate. We'll go ahead and do the implicit derivative on both sides. Will you go ahead and write down what you think that implicit derivative to be? Take about 20 seconds and write down notation for that. What's the derivative of the left-hand side? I'm going to jump down here. What's the derivative of the left-hand side? Just use symbols. F prime of g of x times g prime of x. I hope you didn't have to dig too deep into your memory to get that. What rule is it? Chain rule. What's the derivative of the right-hand side? 1. What's our goal? Our goal is to find an expression for g prime of x. So what should we do? Let's divide. G prime of x is equal to 1 divided by f prime of g of x. Good? We don't like g's in our answer because g was a name we made up for this problem. What should I put back in here? Do you see the connection to what we just did? I want the slope being derivative. I want the slope of the inverse at some x value. It's 1 over the slope of the inverse of the x value. It's what I want you to come away with this is the reciprocal idea. Because those functions are inverses, their slopes are reciprocals at the special points. Now you have to have the inverse points. It's got to be this 2, 0, 0, 2 idea. You can't do it at other pairs of points on the inverse. You can do it at 1, 5 and 5, 1. But if those points aren't the inverses of each other, you can't do it. Okay? Putting it into the context of what we just did, we had f of x is x squared minus 4. And let's say we wanted f inverse prime of 0, because that's what the right-hand side asked us to do, right? We wanted the slope of the tangent when x was 0 on the inverse. We didn't call it the inverse, we called it g, right? But the slope of the inverse is 1 over the slope at 2 on the original, right? The key here is that these 2 points are inverses of one another. 0, 2, 2, 0. Okay? If I want the value of the derivative for an x value on f inverse, I have to take the y value on f inverse and evaluate the derivative there. I'll show you what I mean by that with another example. Okay? We proved it. But it's really hard to understand. Should we go through an example or two? Okay. Let's go to the back of your notes. Okay. I'm going to try to break this down in a little bit of a different way, because the hardest part about this is making sure you're plugging in the right value for the derivative. So here's some information. Okay. We'll just look through the language because all the language is important. It says, use the values of a 1-to-1. If you see 1-to-1 in the instructions of a problem, you're automatically going to go to inverse. Before it even asks the question, when you see 1-to-1, inverses are going to be in play. Okay? Differentiable implies a couple of different things, but key here is you can find its derivative. A lot of times we take it for granted, but a lot of times the language is also really, really important. Compute the indicated derivatives or state that the derivative cannot be determined. Now, let's break this down. Let's take a look at A, and we'll walk through it together, and then you'll try B on your own. Okay? So, I want f inverse prime of 5. What this is telling me is that x equals 5 on f inverse. Right? That's fair, isn't it? Because the x value is always the value that goes in parentheses, right? Good so far? Okay. So there is some point on F inverse that says 5, comma, no idea, right? There's some point on F inverse that has an X value of 5, okay? Using what you know about inverses, tell me about F. Tell me about F. I've given you one thing I know about F inverse. Tell me something you know about F. There's some point on F that has the coordinates something 5, right? Why is that significant? Because we don't have a table of F inverses, guys. We have a table of F's, okay? So now what I need to do is consider what is the X coordinate on F if the Y coordinate is 5. Do you see it in the table? 1. If the Y coordinate is 5, the X coordinate is 1. So on F is the point 1, 5. That's magical. Not really magical, but it's really important. Okay? So here's what I have. There's some point 1, 5 on F, which also means there's some point 5, 1 on F inverse. How are the slopes of those 2 points related? They're reciprocals of one another. 2 reasons. Number 1, I showed it to you with a picture when we started the lesson. Number 2, I proved it with that symbolic stuff. I don't know what makes more sense to you, but I like the picture. Okay? So, which one do I want? Do I want F or F inverse? F inverse. This is the one I want. I want slope there. Okay? What am I going to do? I'm going to use the slope here. I'm going to use that. Use, U-S-E. Use is held like that. Good? What is the slope here? At that point F, M equals what? I think I heard it. 3/2, right? The slope of that is 3/2. You see why? Because when X is 1, the slope, F prime, is 3/2. So if the slope at this one is 3/2, what's the slope at this one? 2/3. Okay? Pictures help me. You know if they help you. I'm going to pause the recording for a second, and I want you to see if you can do the same thing for part B. And if you finish part B really quickly, I want you to try part C too. This one has a value of 2. Not going to go through all of it because most of you had it. Part C, cannot be determined. And the key here for cannot be determined is that we cannot find F inverse of 1 because there's no 1 in the Y row for F of X. So we cannot determine that because we don't know the value of F inverse of 1. Good so far? Okay. Let's go on to this. I want to start by talking a little bit conceptually. This is a 2007 FRQ. Do you remember how many points FRQs are worth on the exam? 9 on the AP Calc exam. There's 9 points. 5 problems, I think. Not that long. I don't remember the exact time. We'll go over more of that later. But here's something that's interesting. It's going to be a little bit easier in the context of this classroom today, but I want you to know the average score on this problem on the 2007 exam. Out of 9, any guesses? 1.6. Okay? So, what I would like you to do is, we read through it first. There's a table given. I don't think you need to study the table. We're going to use it in a minute. But I'd like you to read through it, and we are going to go through A and D together. We cannot do, I think C is crossed out there, right? Or is it not? We can't do C because it's an integral problem, and integral problems are second semester. We actually can't do B either because that's the mean value theorem, and we haven't gotten to the mean value theorem yet. But what I'd like you to do, I'll give you about, I'll give you about 3 minutes or so, and I want you to talk through A, and I want you to do D, and then we'll come back together in just a couple minutes. A couple of you looking at number A, looking at letter A, a couple of you came up with the magical theorem to get you through letter A. How many people think they know what theorem is in play here? We got 3, 4 of you. This is a classic, what? Intermediate value theorem problem. Now, intermediate value theorem, you can shorten to IVT on the exam. Everybody's going to know what you're talking about if you say IVT. Do you remember IVT? It's the continuous one. I'll just draw a really quick picture to refresh your memory. It's the continuous one where I have some interval from A to B, and if it starts here and ends here, all of the values in between, you've got to cross through them, right? So if the key here is you're going to find, well, you need to kind of start at the beginning for intermediate value theorem. What was the qualification for IVT? What was the big one? The function has to be continuous. And what in the description implies continuity? Differentiable. It's differentiable, so then you need to state that since f and g are differentiable, the composition of a differentiable function is also differentiable. You don't need to write it all in these fancy words, but you need to make some sort of conclusion about the fact that h is continuous on AB, on 1 to 3. That's the interval you're looking at. So then what you would do is you'd look at h of 1, you'd look at h of 3. And once you found h of 1 and h of 3, it would be really obvious to you that it's got to be negative 5 at some point. Okay? Going through quickly because we've got a composition minus 6. If I put in 1 for g, I get 2. I put that into f, I get 9. 9 minus 6 is 3. I know I'm going through this fast, but we can digest this a little bit later. H of 3 is a composition. Start with g. G of 3 is 4. Put that into x, I get negative 1. Negative 1 minus 6 is negative 7. Pretty clear right now that negative 5's got to be there? Okay. So you kind of use, well, since h of 3 is negative 7 and h of 1 is 3, there must be an r such that h of r equals negative 5 because negative 5 is in between 3 and negative 7. Okay, something like that is your defense there. Okay. Now we'll do the scoring guidelines in a minute on how many points that's worth. Okay, we'll do that in a sec. So let's go down to D. We're not going to do B. B we'll learn how to do later. We're not going to do C. C we'll learn how to do later. But look at D. Based on what we learned today, is this something we can do? Now, whether or not you can do it in May is another question, but can you do it today is the question. Should we do it together? Okay. We want an equation for the line tangent to the inverse at x equals 2. Okay? So, we're given x equals 2. So, on G inverse, there is a point 2, comma something. Good? Knowing that's an inverse, I think it's really worth your time every time you are given an inverse to invert it and make the other statement. So if this is true, the implication is that on G, there is a point something 2, right? Question. Implication. Implies. Okay? And so let's find this point. Let's find the point. On G, there's a point where the y-coordinate is 2. Go to G and find a y-coordinate of 2. Do you see it? Should I highlight it for you? It's right here. There's a y-coordinate of 2 on G, right? So G inverse of 2 is 1. So we've got a 1 here now, which means we've got a 1 up here. Okay? What is G inverse prime of 2? We learned a reciprocal relationship today. 1 on the top, G prime of what on the bottom? What goes in the parentheses? It's not 2. What goes in? Why do we do 1 instead of 2? I did this last hour. This helped. This helped last hour. I have some, or maybe I did this earlier this hour. I have some point on G 1, 2. That's on G. I have some point on G inverse 2, 1. I want the slope at that. But I know the slope at that. This is 2, 1. This is 1, 2. I need to put a 1 in order to find the slope at G. I reciprocate it to get the other slope. Kind of. Okay. Is 1/5. G prime of 1 in the table is, just want to make sure that's right. G prime of 1 is 5. So the slope that we want is 1/5. I put it all together in a tangent now. Which point do I want? Do I want 2, 1 or 1, 2? I want 2, 1 because I want the tangent to the inverse, which is really weird. But I'm going to use 2, 1. So y minus 1 equals 1/5. X minus 2 is your answer. Okay? Here's the scoring on it. Your intermediate value theorem was worth 2 points. Finding the values of h of 1 and h of 3, and then the conclusion, making sure you're stating the continuity piece and the intermediate value theorem claim. The last problem with part D is worth 3 points. What I'd like you to do is do 3.10 day 2, or is it stated as day 2 or day 3? It's stated as day 3 on your homework outline. These are the problems I'd like you to try. Tomorrow we'll spend some time reviewing. We are testing Monday.